Hi, I'm Megan Bakley. I'm here with Jordan Gerdes, and this is our website for our antibody-based biosensor in order to detect the Ebola virus disease. So, right when you open up our website, you are greeted with some background information on the Ebola virus disease, also known as EVD. It was first discovered in 1976 in the Democratic Republic of Congo in Africa. EVD outbreaks have been known to affect many African countries. Most recently, you may remember the devastating 2014 outbreak that lasted until 2016, killing thousands of people with more than 28,000 cases. As we scroll down here, you can see a pamphlet from the CDC about the transmission of EVD. It's contagious and spread through bodily fluids and contact with surfaces or things that have been contaminated with bodily fluids. Further down here, you can see the pathogen. That is the Ebola virus. And then also as we scroll down, you can see symptoms. Some of the symptoms are very similar to those of other common diseases in the area. So it's important to be able to identify EVD as soon as possible, just because it is so contagious. And then lastly, down here at the bottom is a video further explaining EVD and how someone who's infected with EVD, their blood is treated as biohazardous material, so it's pretty severe. And then under our homepage, we have our current methods of detection. This is currently a PCR test. Underneath here, we also have a video from the 2014 outbreak showing just how helpful rapid detection would have been during this time. And they actually did try to come up with a rapid detection test. And again, as I mentioned, the blood of someone who's suspected of having EVD is treated as biohazard material because it's just so contagious and so toxic. And then under our bioreceptor page, you can see a brief description of our bioreceptor. That would be the glycoprotein. As you can see here, it's the outermost protein on the Ebola virus. And then on our biosensor page, you can see a quick overview of our biosensor, which is seen here.
As you continue to scroll down, you can see our chosen transducing materials, our immobilization chemistry, and our signal generation. This biosensor design will be using gold nanoparticles as our transducing material. They are widely used because of their ease of synthesis, adjustable size and shape, and their remarkable biocompatibility, as well as their unique optical properties and surface plasmon resonance properties. The immobilization chemistry we chose was the passive absorption. The choice of immobilization chemistry depends on various factors and has a significant impact on the performance and sensitivity of a biosensor. This is a random non-covalent attachment immobilization chemistry. We found that NCBI claims passive absorption of antibodies onto a support is the simplest approach for immobilization. As you scroll down, you can see our signal generation. For the signal generation of our biosensor, we will focus on electrical signal generation, more specifically an FET or field effect transistor. A transistor is a semiconductor device used to amplify and switch electronic signals and electrical power. Transduction is achieved by modulation of channel convectivity when charged biomolecules are captured by the gate. Major components of these FETs include the gate, the drain, and the source terminals. They also, in some cases, have a fourth terminal called the body, base, bulk, and or the substrate. To find out more information about our transducing material, our immobilization chemistry, and signal generation, click on the headers to be taken to their specific pages. Moving on, under our form factor and packaging tab, you can see a video that provides more insight on the specific form factor and packaging of biosensors used for Ebola virus. You can see our steps for detection. The first step is to collect a sample from the patient's mouth via mouth or nasal swab. The second is to mix the sample with our given solution. That solution will then be poured into the sample well, and then the patient will need to wait the allotted time period before checking results. Once identified, the FET will say whether or not the patient has the disease on the testing screen. So for real life applications and use, this equipment would ideally be used at home by patients who believe they could have the Ebola virus. In order to prevent further outbreaks, those who believe they have EVD can use the test at home. Since blood samples of people that have EVD require PPE, a saliva or nasal swab test will be used. Although it is still a bodily fluid and can cause contamination, it is less severe than blood. The accessibility and ease of use of this product will give populations a peace of mind. While they may be sick, now they will be able to determine their illness from the comfort of their home, helping to prevent further devastation and outbreaks from occurring. And then under our More tab, you can see the lessons learned from this project. You can see a little bit about ourselves and then more details into what we have learned from this project. Under the website walkthrough, you will see this video that will help you navigate through our website, and we hope you enjoy watching. And then also you can see our references for this project. Thanks.